Let's take a look at some examples of multiple angle and product to sum problems. Our goal today is going to be to again apply these formulas to evaluate some trig expressions. In the first example we have today, we're given a right triangle. We can quickly do Pythagorean theorem or recognize this is a 3, 4, 5 right triangle to get the first piece of information we know. We're asked to find the sine of angle alpha, which is going to be opposite over hypotenuse, 3 over 5. If you needed to know the cosine, it would be adjacent over hypotenuse, or 4 over 5. The tangent is going to be opposite over adjacent, 3 over 4. Sine of twice an angle. Remember that our sine of a double angle is going to be 2 times sine alpha times cosine alpha. We know both my sine and cosine, so it's going to be 2 times 3 over 5, which is my sine of alpha, and times 4 over 5, which is my cosine of alpha, which equals 2 times 3 is 6, 6 times 4 is 24, 24 over 25. Cosecant is the reciprocal of sine, so if sine of 2 alpha equals 24 over 25, cosecant of 2 alpha equals 25 over 24. The second example we're going to look at today is an equation. We're going to solve for the interval 0 to 2 pi, the equation 4 sine of x times cosine of x equals 1. And we're not really that good at solving things with two trig expressions, so let's see if we can write this in a single trig expression, remembering that sine of twice an angle equals 2 times the sine of that angle times the cosine of that angle. So what I really have here is 2 times 2 sine x cosine x equals 1. So I have my double angle formula multiplied by 2. If I plug this into the right side, it's going to spit out sine of 2x. So I have 2 sine of 2x equals 1. Divide both sides by 2. I've got sine of 2x equals a half. I know that this is true if I take the arc side of both sides. So arc sine of 2x equals arc sine of 1/2. This is going to be true at pi over 6 and also at 5 pi over 6. What I need to do is establish what my x is based on these being the 2x. I can divide both of those by 2, get 5 pi over 12, and pi over 12 for my first two solutions. There are also going to be some solutions at the higher end that are going to multiply 2 5 pi over 6 and pi over 6, but let's let those be for now. Once again, for the interval 0 to 2 pi, let's solve for x. Given the equation sine of 6x plus sine of 2x equals 0. For this, let's try to use one of the sum to product formulas which looks something like this. If I got sine of u plus sine of v, I can rewrite that as 2 times sine of u plus v over 2 times the cosine of u minus v over 2. My u and my v are going to be sine of 2x and sine of x. I'm sorry, sine of 6x. And I can rewrite this as 2 sine of 6x plus 2x over 2 times cosine of 6x minus 2x over 2, which is going to give me 2 times sine of 4x times cosine of 2x. Which equals 0. Since we have this set up as a product now, I know that either sine of 4x equals 0 or cosine of 2x equals 0. And what we're looking for are any values between 0 and 360 or 0 and 2 pi that will make either of these true. Sine of an angle equals 0 at 0 or at pi radians. What this is going to make true is that x could equal 0, x could equal pi over 4. However, if I plug pi over 2 in, pi over 2 times 4 is going to give me 2 pi, which also has a sign of 0. If I plug pi in, 4 pi is equal to 2 pi, which is also going to give me 0. If I plug 3 pi over 2 in, that's going to give me 6 pi, which also equals 0. If I plug, is there anything else that works? 5 pi over 4 times 4 is going to be 20 pi over 4 is 5 pi, which also equals 0. 3 pi over 4 equals 3 pi, which would also equal 0. So instead of our two solutions of 0 and pi, we're going to have many solutions. Every pi over 4 is going to be a solution. So I have pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 2 pi, but 2 pi is excluded from our interval. If cosine of 2x equals 0, what that's going to give us is that 2x equals pi over 2 and 3 pi over 2. So we're looking for any values that multiply to either one of these. And I think those are actually all covered in the values we found for sine. So we're all set.